This is asking you very typically, if you wanted to make this much of molarity of KCl, then how would you do it? Okay, so again, your formula is always going to be, of course, molarity is moles over liters. So since you have the volume and molarity, you will calculate for moles. Okay, first. So the molarity is 2.45 divided by, multiplied by, convert this to liters. Okay, make sure to do that, 0.05 liters. And what's the answer? Anyone?
0.1225.
0.1225?
Yeah, that's what I got.
Okay, that's the moles. And then once you have the moles, then you will go ahead and convert that into grams, okay, of KCl. So that's all you have to do in this one. Okay, and this is again a very typical question that would be asked of you. When you're doing dilution, you're adding more of the solvent. If you add more of the solute, that's not called dilution, okay, because what you're doing by adding the solute is by making it more concentrated. Okay, so you don't add solute to make it diluted, you add more solvent, okay, for dilution. So usually in labs what happens, and you will find this, it's a very common thing, okay, is that you may have a 12 molar solution of, say, sulfuric acid, and what you need in the lab is 6 molar sulfuric acid, okay, which is half the concentration, okay, of what you need. So what you will do is you will take a certain amount of sulfuric acid and add water. You can keep adding water until it is 6 molar, but how much water do you need? That is what dilution problems are about, okay? All right, but before I get into that, I need to ask you one little question, okay, is if you've ever had this, and I don't really buy frozen juice anymore, but if you do get frozen juice, all right, so you get a can of frozen juice. You have to add water to it, correct? Yes, and it will tell you that you should add 2 to 3 cans of water depending on how concentrated you want the juice to be, okay? And so typically I think it's about 3. So you have 3 cans of water and 1 can of juice, okay, that you have. So in the end, how much total juice do you have? How many cans? At the end, 4. Okay, so you have 4 cans. 1, 2, 3, 4. There are 4 cans of juice. Are we good so far? Okay, there's a point. There's a point. And the point is, you started with this 1 can of juice. Is that 1 can of juice still here?
Yeah.
Yes, right? Because the rest of it is water. Good? Now I want you to think of that can of juice as the moles. Okay, as the moles. So if you have a certain amount of moles in here, do you have the same amount of moles here? Yes?
Yeah,
Yes, exactly. It's just diluted, right? But the same amount of moles is there, you just have more water in it. Do you see the point? Okay, and that's the point. Okay, is that your number of moles has not changed. All right, so in dilution, this is your moles, and I'm telling you that this moles has not changed. Okay, so what I'm saying is that the number of moles you have here, moles initial, is equal to moles final. Okay, and how do you calculate the moles initial? You calculate it by moles times liters, and that's initial, and then you'll have moles times liter, and that is final. Okay, that's how you arrive at that formula, which tells you how much of water you can add. Okay, so you still need the molarity, you will need how much volume you need to have, okay, initially, and then the molarity and the volume of the final. Okay, that's how you get it. And you can do this only because the number of moles are constant. Okay, they have not changed from the initial to the final. Only the amount of water has changed. So let me write the formula in a better way. That's our formula then. Okay, M1 V1 is equal to M2 V2. So we have the initial volume and the initial molarity, and then the final volume and the final molarity. These kind of questions are again very easy to do. The only problem that I find sometimes is when you're not consistent with your numbers. Okay, that's kind of what happens. So if you take the initial and multiply it by the final, that's not going to work. Okay, you have to keep your initials together and your finals together. So question number 8. Okay, in your problem set here, what volume of, question number 8, what volume of 6.0 molar sulfuric acid is needed? So we know the molarity, and the question is asking for volume, is needed to make 500 milliliters of 0.25 molar sulfuric acid. With the problems is that you pull out all the numbers and then you put them together. If you were doing this calculation, look over here for 1 second. And we're going to do this in our minds. Okay, we're not going to write anything over here. I want to make 100 milliliters of a 6 molar solution, and I have 12 molar solution of this. How much of the 12 molar do I need to make 100 milliliters of 6 molar? And how much water am I going to add?
Half of the,
6.
half of the 12 hours.
Yeah.
So I need half of what? Go ahead, don't be afraid.
You need half of your 12 molar solution.
Half of my 12, right? So since I need 100 of this, I would take half of this.
You double that.
No, I would double that. But I need to make only 100 milliliters of solution. I don't need 200 milliliters. Anybody else? Conceptual problem. Okay, here's another way of looking at it. Here's a glass of milk, and I need to dilute it down 2 times. What would I do? How much water? Not just add water. I know I have to add water. How much water should I add? 2 glasses of water or 1 glass of water?
2, the same volume of what you start with.
And that will give me half the milk I had in there before, right? It's diluted down now.
That would, if you added 2 cups, that would give you,
Okay, so this is full. This is a full glass of milk, all right? And I need to make 2 glasses of it. How much water do I add?
The same exact amount.
That's exactly what this question is. That's exactly what this question is, okay? Except that I didn't start with 1 glass. I told you I need 100 milliliter, right? So you would start with right? You would start with half of this, okay? You would start off half with this, and how much water are you going to add to this? Okay, you're just going to double this, right? Because you need half of the concentration. Do you see where I'm going with this? Concept. Not everything has to be done by calculations, okay? You need to understand the concept of dilution so that when you have your answer, you know that it's a correct answer. But if you don't understand the concept, it's going to be tough. So you add 50 milliliters of water. So at that time, you have double the water, double the volume, okay, in there. And because you added equal amount of water, you just divided this by 2. Got it? So now you have half the concentration. So I just worded the question differently for you with the milk example. Okay, that if you needed to get 2 glasses of milk from 1 glass of milk, you would just add equal amount of water to it. Okay, and you would get 2. And the amount of milk is still the same, it's just diluted. Okay, the moles of milk that you started with is still the same. Okay, it's just you've added more water to it. Are you good? Are you okay? All right, so that's what the concept of dilution is. So here also, it is a ratio thing. Okay, here also it's a ratio, but sometimes diluted one, right? This is the diluted and this is the concentrated one. Okay, and so Do you think you will need less volume over here or more volume here? Less or more? Pick one. Less or more? Pick one. Okay, less. We'll find out. We'll find out. Okay, so whichever one, the diluted or the concentrated, is your M1, the other one is your M2. So 6.0 molar times volume is equal to 0.25 molar times, convert this to liters, 0.500. I can leave it as 500 milliliters because I'm calculating for volume. Okay, if I was calculating molarity, I would certainly change it. But because I'm calculating volume, I can still get away without converting, but I will still convert anyway. So volume here is then cross multiplication, 0.25 molar times 0.500 liters divided by 6.00 molar or 6.0 molar, whatever it is, it doesn't matter. And your answer comes out to be 0.0208 liters. So if you said less without looking at the answer, okay, and you're on the right track. What happened? Sulfuric acid, right? That's what it means. But it doesn't mean you're finished with the problem yet. Okay, so let's see. Well, you're technically finished with the calculation part. Okay, but what do these numbers really mean? Is that here is again our wonderful volumetric flask. You will take 20.8 milliliters of 6 molar H2SO4, right? That is how much of the sulfuric acid that you need. Will you add 500 milliliters of water to this, or will you add less than 500 milliliters of water? Just a simple question, no numbers yet. Will you add 500 milliliters of water to this to make it to 0.25, or would you add less than that? Less. And you say that because. So if you add 500 milliliters of water to this, will you get 500 milliliters at the end? No. That was it. That was my question. Will you add 500 milliliters of water? You should have just said no, because if you add 500 milliliters of water, your final answer is not going to be 500 milliliters. It's going to be 520.8 milliliters of water. That's what I was trying to get for you to think, okay? So you don't add 500 milliliters of water, you add minus that much amount of water, okay? So if you know how much cream you want to put in your milk, you will take less coffee accordingly, okay, for that. So you can compensate. That's exactly what we have to do here, okay? So we get our volumetric flask again. This one is going to be a 500 milliliter. So you can do it both ways, okay, if you want. If you have a volumetric flask for 500, you go ahead and add the 20.8 milliliters here and then fill the rest of it with water, okay? But technically speaking, how much water are you adding? You are adding 500. How much? 479.6. No, 2. Technically, that's the amount of water you're adding. Okay, so if your quantity was 400 milliliters, for which you don't have a volumetric flask, then you would have to subtract the two numbers to find out exactly how much water you need to add. Got it? Okay, so don't take your question at face value and say, oh, I just need to add 500 water. No, you don't need to add 500 water. You need to add less than that water. Okay? You need to actually make it up to 500 milliliters. Okay? That's how we answer these questions, is you take the 20.8 milliliters of the acid and you add enough water to make it to 500. Okay? That's how we answer these questions.